In section 3.3, we learned a bunch of different rules for taking derivatives. The first and easiest of the rules, namely that the derivative of a constant is 0, the derivative of x is 1, that if I have a constant times a function, then I could just take the constant times the derivative of that function. The power rule, everybody's favorite rule, that you can bring the power down and then take your function u to the n minus 1. Now technically it's times u prime, but we haven't dealt with that yet. That's section 3.7. So for us it's always just x to the n minus 1 times 1. And then we saw the sum and difference rules. And then we also saw e to the x. The derivative of e to the x is e to the x. Simplest derivative there is. All right, so now we need to learn this rule right here. We need to learn what to do when we have a product. So a product is going to be a little bit more complicated than what we've used so far. So let me remind you of the power rule. So if I have a function a of x, then the derivative a prime of x is 5x to the fourth. That's the power rule. So I'm using rule number 4 for this one, power rule. And then if I have 2e to the x, the derivative of that would be b prime of x, which is 2e to the x. I'm technically using two rules there. I'm using the constant multiple rule, which is rule number 3, and that deals with the fact that the 2 is there. And then I'm also using the fact that the derivative of e to the x is e to the x, which is this portion right here. So the 2 comes from the constant multiple rule. The e to the x comes from the fact that the derivative of e to the x is e to the x. All right, then I could sum them, and that would be rule number 5, the fact that you can sum or difference those. So the derivative of 2e to the x, we just said, is 2e to the x. So if I want c prime of x, that would be 2e to the x plus, and then the derivative of the x to the fifth, which is 5x to the fourth. And there we have it. So no problem, everything for A, B, and C we already learned. But the thing for D is that we don't have a rule for this. This is a product. Well, we do have a rule, but we don't know it yet. So this is the product of two functions. And so we need a new rule to do this. All right, now before we go define what that new rule is, let's look at a different way of doing this. And we have to do this with a different problem because the problem we're having cannot be algebraically simplified. So I have this function which is x to the fifth, sorry, I got off. X to the fifth plus 2 times 2x to the third plus x squared. Okay, so what I can do is I can use algebra, not calculus, but algebra, and I can expand and simplify this problem. Well, actually, it's not simplifying it, it's just expanding it. So I could rewrite y equals first outers inners less, because that's what FOIL means, right? FOIL is expanding, also known as distribution, if you had an instructor that used the distribution word. Okay, so that would be 2x to the 8th plus, that's firsts, outers is x to the 7th, inners is 4x to the 3rd, and last is 2x squared. All right, so there is the same function, but expanded, right? So use algebra to expand. I haven't used any calculus yet. I haven't found a derivative. This is actually the same function. It's y. But now I want to use calculus and find the derivative, right? So, well, that would be y prime, which is y prime of x, also known as dy dx. Whichever one of those notations makes you happy. They're all the same. They all mean the derivative. So bringing the 8 down, 2 times 8 makes 16. Subtract 1 from the power, 7. Plus, bring the 7 down. 7x to the 7, take away 1 is 6. Plus 12x to the, because 4 times 3 is 12, to the 2, plus 2 times 2 is 4, x to the 1. And there we have it. Here's the derivative. But this isn't going to work all the time. There are a lot of functions that cannot be algebraically manipulated like this. So let me write that down. So for example, our d of x function, algebra would not help at all. It would actually be impossible for that particular function. And then there are a lot of times where it's just too cumbersome. We want another way, a better way, that will work no matter what, even without using this algebra step right here. And that is what the product rule can do for us. The product rule will find the derivative of two functions that are multiplied, and it'll work without having to expand the function out, which is good because a lot of functions cannot be expanded. Now, if you look at your gold sheet, it's actually rule number 7. It's saying if you have two functions u and v and they are multiplied, then the derivative d over dx of that multiplication is the derivative of the first function u times u prime times v plus, and then leave the first function alone, u times v prime. On our sheet here, it's f and g. So it kind of doesn't matter which way you want to think about it. You can use it as f and g or u and v prime. They both have their uses. Honestly, in Calc 2, we tend to use u and v more often, and in Calc 1, we tend to use f and g more often, but you know, it's not a hard and fast rule. All right, so this would allow us to be able to find the derivatives of the products of functions without having to use algebra. So no algebra required necessarily. All we would need is the derivatives of each of the individual functions, which is nice. All right, so let's look at the example 1D above, which was impossible actually before. So you can see you have your function, and you can label these as either u or v or f and g. It doesn't really make any difference. So I'll call it f right here, and I'll call this function g right here, and you'll notice they're being multiplied. So according to our product rule, d prime of x is equal to, so I take the derivative of f. Well, the derivative of f is 2e to the x, because e to the x is its own derivative, times, leave g alone, so x to the 5th, plus, now leave f alone, 2e to the x, times, and derivative of g, 5x to the 4th. So this right here is f prime, this right here is f, this right here is g, and this right here is g prime. And you're kind of done. I mean, you could simplify it if you wanted to. You could factor a 2e to the x out of both terms, but they didn't particularly ask you to, so you don't have to if you don't want to. So it would be 2e to the x times x to the 5th plus 2e to the x, oh, actually 10. Sorry, that we could do, because 2 times 5 is 10. So that would make 10 e to the x times x to the 4th. Right? All I did there was multiply 2 times 5 to get me 10. All right, then let's use that same rule for the problem we did earlier. So this, without expanding it, let me just write it. dy dx, aka y prime, would be equal to, okay, so I want the derivative of this. So let me call this f. The derivative of f, which is f prime, would be 5x to the 4th. Right? The derivative of 2 is constant, so that goes away. Derivative of x to the 5th is 5x to the 4th. And then I leave the 2x cubed plus x squared just sitting in there. That right there is g. And then I reverse it. So now I'm going to leave f alone. So I'm going to write x to the 5th plus 2, and then I write it times the derivative of g, which is 6, 2 times 3 is 6, x to the 2nd plus 2x. So this would be f right here, and this would be g prime right here. All right, now I know you're thinking, well, that doesn't seem the same at all. And this would actually be, if they don't ask you to simplify it, you could actually be done right there and say, I'm finished, right? Which a lot of the time I will do. So a lot of the time I just want to make sure you can apply the rule and I don't need the simplification. However, if I ask you to simplify it, that would be to multiply. So 5 times 2 is 10. X to the fourth times x to the third would be x to the seventh. 5 x to the fourth times x squared would be plus 5x to the sixth. I'm distributing that 5x to the fourth times both of those terms. Plus, and then over here I have a binomial times another binomial. So I'm going to multiply or FOIL. So x to the fifth times 6x squared would be 6x to the seventh plus 2x to the sixth plus, that was outers, inners is 12x squared, and lasts is 4x. Combining like terms gets me, let's see, this one and this one are like terms. So that makes 16x to the seventh. And then this one right here and this one right here makes 7x to the sixth plus a 12x squared plus a 4x, and lo and behold, that's exactly the same answer I had before right here. See, it works. So this is simplified. Now, a lot of the times I will ask you to not simplify. Yet again, I'll reiterate that fact. Just because I don't necessarily want you to. I just want you to prove that you know the rule and know how to correctly apply it. Getting from here to here requires correct algebra. Right? Just doing this part is calculus. So sometimes I won't make you do this extra step in here. So look for the instructions and see what I ask for. Is same as found previously. And I'll just make a note of the, be careful to look out for your instructions and follow what the instructions ask for. I cannot tell you the number of students that have done this step correctly, but then do this step incorrectly, and so they lose points, and it wasn't asked for. So if you're not asked to simplify, then don't. Then just leave it up like that. All right, so which method would you use then? Well, the answer is it kind of depends. It depends on the problem, it depends on the difficulty, it depends on what you're trying to use it for. So it depends. So usually we use the product rule first. So the second method, the method I'm using here, usually that's the one we use, method 2, unless the algebra is particularly easy, right? So the algebra step, which is what we did first in method number 1 on the previous page. And if that's very, very easy and it's obvious, then we'll do the algebra first. Otherwise, we tend to use the product rule.